Okay, so example 1, if I give you 3x plus 2 equals the square root of 2x plus 7. So everybody write that down. Let me hit pause. So here's the overarching theme. When you're solving equations with radicals, you get rid of the radical, right? That's your job, right? You get rid of the radical, then you can go back through and solve it. So to get rid of the square root, what do you think we're going to do? Oh, actually, let me go ahead and clear up the rules. Whatever you do, you have to do to both sides. So what could I do to both sides that would get rid of the square root? Okay. What would happen if we squared both sides? What happens when you square a square root? It cancels it out, right? And so we're going to square both sides, and when we square both sides, this is going to give us 3x plus 2 equals 2x plus 7. Well, now that's really not much of a question, is it? Right? We got rid of, and when I got rid of this, and now when you solve, you end up with what? Subtract 2x from both sides, I get x equals 5, and we're done. Does that make sense? Another way of thinking about this, and well, we'll talk about that later. All right, so actually for the next few problems, our goal is, if you see a square root, you square both sides. So this is like this is probably the easiest problem I could give you. You just square both sides. Well, let's look at another one. So what if I give you 2 plus the square root of 3x minus 2 is equal to 6? Okay, so I'll do this one, all right, and then I'll give y'all one to do. All right, your job is I want to get rid of the square root, right? And we know that if we square it, we get rid of the square root. Does that part make sense? So, but there are a couple of things I want to make sure you're aware of. Squaring both sides at this stage is not pleasant. Right? Squaring this is fine. All right? Squaring this is absolutely hideous. Right? This is effectively a binomial, and it gets really ugly. Right? So kind of your plan is, whenever you're solving an equation with a radical, you want to get that radical by itself, right? And so if I get my radical by itself, all right, I'll subtract 2 from both sides, so this is going to give me the square root of 3x minus 2 equals 4. Right? I like the way this looks, because now I can square both sides and things are not particularly ugly. So I'm going to square both sides, and that's going to give me a 3x minus 2 is equal to 16. And I get 3x, add 2 to both sides gives me 18, and end up with x is equal to 6, and everybody's happy. Right? Everybody understand the logic in that? And actually, in general, the logic is whenever you've got radicals, get the radical by itself, then square both sides. So, your turn. If I give you square root of 5x minus plus 1 is equal to minus 6 is equal to 0. All right, so everybody do this, and when you get the square root by itself, and so I end up with 5x plus 1 equals 6. Square both sides, and then I get 5x plus 1 is equal to 36. 5x is equal to 35, x is equal to 7, and everybody's happy, right? Okay. Seem pretty easy so far? Okay. So what happens about this one? Looks almost the same. Let's say I give you square root of 5x minus 1 plus 3 is equal to 0. Solve that one. I mean, so you go through, right? So can we approach this problem the exact same way we approach this one? Get the square root by itself. And so we end up with 5x minus 1 is equal to a negative 3. And let's see, we square both sides and end up with 5x minus 1 is equal to 9. 5x is equal to 10. X is equal to... Did everybody do something that's similar to that? Why do I have a problem with x equals 2? We did the same thing, didn't we? Right? We did the exact same thing on this problem. Why do I have a problem when there's x equals 2? Does 2 work? Well, wait, what does it mean by that? You said no. What do you mean it doesn't work?
Well, when you plug it into the 5, you get 9, positive 9, and then 3 plus 3 doesn't equal 0.
Oh, it doesn't work, does it? Does everybody see that 2 doesn't work? What happened? Right? Didn't we do the same thing? Right? We did the same thing. 7 does work in this case, by the way. Right? So, we've had this happen before. Yes? What?
I was going to say there's a negative in the box
You have negative in here? That's not why. But you are looking, it does have something to do with the minus sign. It definitely does. So 2 is an extraneous answer. Did we ever have an extraneous answer before? When we were solving equations, did we ever solve equations and like some answers didn't work? When was that? What did the equations look like that we had answers that didn't work? We had fractions. You remember when we had fractions, we were solving rational equations? And when you're solving rational equations, you would work a problem and then you had to make sure that it was legal. You remember that? And the reason you had to check to see if something was legal is we had something with it, the official title is restricted domain. Basically, it's stuff that doesn't work. You have some restrictions. And right now, you have 2 rules. You can't divide by 0, so anytime you see a fraction, you have to make sure that what's in the bottom is legal, right? And you can't take the square root of a negative. And so anytime you see square roots or you see fractions, you have the potential of problems, right? So anytime you solve something with a square root, just because you get an answer, you have to check to see if it works. Now, unfortunately, you really have to check. Like with a fraction, you just have to make sure your bottom doesn't equal 0. With this, you actually have to go check. This is actually a pretty simple example. You can actually find out it messed up here. Notice it says square root of something equals negative. Can a square root ever be negative? So at this point, we had a mistake, right? But you don't always see it. All right? So, before we do the next problem, I just want to make sure there's a certain skill I need to make sure you have. Right? All right, so this is scratch work. This isn't part of the actual lesson. But this is a skill you desperately need to have. All right? So on scratch work somewhere, if I give you x minus 5 and I square it, I don't want you to write the problem. I want everyone to write down what x minus 5 quantity squared is just somewhere, right? Okay. All right, it should be written down now. Right? Did you write down 3 terms? All right, if you didn't write down 3 terms, we've got a problem, right? But when you're squaring a binomial, you're going to get 3 terms, right? And I need to make sure that this is instant. This is not something where you see x minus 5 squared and you think this is x minus 5 times x minus 5 and do the FOIL or whatever you did before. If you see x minus 5, you need to know this is x squared minus 10x plus 25. And that needs to be instant. Right? It has to be instant, because if this isn't instant, the rest of these problems are going to be really hard. Right? Now, here's how you can make it instant. Anytime you square a binomial, you're going to get three terms. Square this one, and you get your middle term by multiplying these together and doubling it. And so when I multiply these together, I get the negative 5x. When I double it, I get negative 10x. Right? But it's incredibly important that if you see this, you can write this down instantly. Okay. Is everybody okay? Huge skill. All right. So how do we use that skill? Let's say I give you the square root of x minus 3 plus 5 is equal to x. All right. What do you do first?
Subtract the 5.
Get the square root by itself, right? Right? That's been our goal. When you're solving radical equations, you get the square root by itself, all right? And when I get the square root by itself, it's going to give me the square root of x minus 3 is equal to x minus 5. Now what do you do? Square both sides, right? The whole reason you got the square root by itself is so that you can square both sides. All right? So what's this side become? X minus 3. So this becomes x minus 3. What's this become? X squared minus 10x plus 25, right? Do you see why having this skill where it's instant is huge? Right? Let's go ahead and give a preview. All of the other problems that I have written on my page, except the ones that right at the end, hinge on the fact that from here to here is instant. All right. So now what?
Set it equal to 0.
What have we done every other time we've seen an x squared and x in a number, right? Set it equal to 0 and hope the thing factors. So I'm going to move this stuff over. I mean, I guess technically you can move this, but I don't like dealing with that. I'm just going to move these over. And so that's going to give me 0 is equal to x squared minus 11x. What's that? Plus 22. Did I mess up?
You have to add the 3.
Add the 3. Good, because otherwise I'm not going to... I wasn't going to get the answer that I wanted. And now, that whole factoring thing, right? So let's see, we factor. So we get 0. Let's see, that's x and x. Oh, 28, I guess that's 7 and 4. So minus 7, minus 4. So what are my answers?
7 and 4.
So we think our answer is 7 and 4. I got a problem. All right? We started with a square root, right? Anytime your equation starts with a square root, you got to check to see if these work. How do you check if they work? Sorry, you have to plug it in. All right? We have to see if it works in the original problem. So to see if this thing works in the original problem, let's see, I'll put the 7 in, and so let's see, what do I get? So the 7's going to go here. Usually, it's actually easier to check these than you think. You just have to get used to it. So I get 7 minus 3, which is 4. Square root of 4 is 2. Is 2 plus 5 7? Yay, that one works. Okay? Let's try 4. And so when I try 4, let's see. 4 minus 3 is 1. Square root of 1 is 1. Is 1 plus 5 4? What? 1 plus 5 is 1 plus 5 4? I'm making sure, right? Okay. So this doesn't work, right? And so our only answer is 7. Does that make sense? Right? So, are we okay with this part? Right? So No, this was, there's no way to know this without actually physically plugging stuff in, right? You have to check. Now, here's a little secret. Usually when you solve these and you get two answers, I'm going to go out on a limb and say 95% of the time, one answer works. All right? Sometimes both answers work. Sometimes, right? You got to do a lot of work for both answers to work. And sometimes no answers work. Right? But most of the time, one of the answers doesn't work. You only get one answer that works. We okay with this? All right. So now, here, warm up for this. Scratch works somewhere. You got your scratch work somewhere? Okay, this is one of those cases. This isn't this is not an equation. This is just a skill. We're gonna revisit this skill. When I square this, how many terms am I going to have? I'm going to have 3, right? Are we okay? Is that obvious? Anytime you square a binomial, you're going to get 3 terms. And so when I square it, well, let's see, what's this one square going to be? 25, so that part's easy. When you square this, what do you get? Plus, you said it.
Y squared.
No. Square, what's the square root of y squared? I heard it. Y. Wait, does that make sense? You squared the square root, you just get y, all right? And it's plus. Okay? What goes here? Negative 10, what? Negative 10 square root of y. Right? Remember the trick? You multiply these together and double it? If I multiply these together and double it, I'm going to get minus 10 square root of y, and I still get the plus y. Does that make sense? All right, remember that skill? Right, we're going to square a binomial. I need to make sure when you square it, first, you know it's 3 terms. You know what the first term is, you know what the last term is, right? Is the first term and last term pretty easy? And then your middle term, multiply these together and double it. Right? We okay? So now that we have that skill, right, let's look at the problem. So now, what if I give you the square root of y plus the square root of y plus 5 is equal to 5? Give you a little bit of time to write that down. All right. Everybody got it written down? Now our job is to get rid of the square root. Oh, wait a minute. What's our problem? Like what we've done in all the other questions is we get the square root by itself and then we square both sides. What's different about this?
There's just square root.
What?
You can have to square.
You got 2 square roots. Right? Does everybody see we have 2 square roots? What do you do when you have 2 square roots? Right? Everybody understand the question? Like all the other ones I've given you, you had 1 square root, and you said, okay, we're going to get the 1 square root by itself, everything else on the other side, we're going to square both sides, and my square root goes away. What do you do when you have 2 square roots? Okay. What you do when you have 2 square roots is you identify the most complicated square root and get that by itself. So which is the most complicated square root?
Y plus 5.
Is everybody okay? Is it obvious this is the most complicated square root? Get this by itself. Okay. So to get this by itself, all right, fine. I've got square root of y plus 5 is equal to 5 minus square root of y. Everybody okay? We got this complicated square root by itself? Now what do you think I'm going to do? Square both sides, right? So kind of the big picture here is you can't get rid of two square roots at the same time. It's not possible. So don't try. Where I see a lot of students really start making a lot of mistakes is they try to get rid of both square roots at the same time, and you can't get rid of both square roots. All you can do is you get rid of one square root, and then you get rid of the next one. So to get rid of one square root, we're going to square both sides. And what's this become? This becomes y plus 5. What's this become? We just did it. When you square this, what do you get?
25 minus 10.
25 minus 10 square root of y plus y. Are we okay with that? All right, now what? We still got to get rid of the square root, right? What would you do if this was your original problem? How could we solve this? Well, what's our goal? What's our goal when we're solving equations with square roots? If you see any equation with a square root, what's your goal? What's your first goal? Well, before you get rid of the square root, what do you need to do? Get the square root by itself. Isn't that what we've done on every other problem? Every problem we've gotten the square root by itself. So if this is your problem, could you get the square root by itself? Right? Right, so you get the square root by itself, and you think, well, all right, well, I'm going to subtract y from both sides. I'm going to subtract 25 from both sides. Is everybody okay with that? So this cancels. Oh, that's nice, right? Now you get negative 20 is equal to a negative 10 square root of y, right? Now what do I do?
Divide both sides by negative 10.
Yeah, we're getting the square root by itself. We're going to divide both sides by negative 10. So I end up with the square root of y is equal to 2, right? And now what's our final step?
Square both sides.
Square both sides. Remember, we got the square root, like the whole reason we got the square by itself is so that we could square both sides. And when I square both sides, what do I get?
Y equals 4.
Everybody see we get y equals 4. Are we done? No. Unfortunately, you got to check to see if it works. Right? Because it is very possible in this situation where you can do all this work to get here and your final answer doesn't work. Does this work in the original problem?
No.
Well, let's see square root. I mean, what you do is just like a little check. Square root of 4 is 2. 4 plus 5 is 9. That gives us 3. Is 2 plus 3 equal to 5? Yes, we're fine. All right, your turn. So again, just recapping. Whenever you have multiple square roots, step 1, get the biggest square root by itself. All right? Square both sides. Right? Remembering our little trick. Then you're going to have a square root left over. Get that square root by itself. So what if I give you the square root of x minus 3 plus the square root of x equals 1? Pause. I think I'm going to hit pause. Okay, I think most people have got an answer. So this kind of works the same way as the other one, doesn't it? You go through, and okay, we're going to subtract the square root, get this by itself. So that's going to give me the square root of x minus 3 is equal to 1 minus the square root of x. Okay. Then what do we do?
Square both
Square both, right? I mean, that was our whole point. We wanted this square by itself so that we could get rid of it. So we square both sides, and that's nice. That gives us x minus 3. And now remember that trick I said it's got to be instant, right? Because if that's not instant, then this problem gets way, way harder. So this gives me a 1 minus 2 square root of x plus x. So far, so good. And now get this thing by itself, right? So let's see, subtract x from both sides. Well, that's convenient. These go, if I subtract 2 from both sides, I get a negative 4. It's equal to negative 2 square root of x. I'm going to divide everything by negative 2. So I get square root of x is equal to 2, and we end up with x is equal to 4. Are we okay so far? Are we done? No, we got to check, don't we? So we go back in and say, well, 4 minus 3 is 1. Square root of 1 is 1, and square root of 4 is 2. Is 1 plus 2 1? So our one chance of working doesn't work. So guess what we write down? No solution. All right. I know sometimes that's not very satisfying. It's like, I did all this work and I get no solution. And, well, yeah, sometimes that happens. Okay. All right. Okay. Are we okay with these? Before we do the next problem, I really want to, stress on this one particular skill. Let's see. This is scratch work somewhere. This is not part of your real notes, right? This is just scratch work somewhere, right? And again, this sounds mean, right? But I need this to be instant too, right? And actually, before we do this problem, I want to do a generalized version of it. The generalized version of it is, if I gave you 1 plus a happy face squared. Actually, square root of happy face. If I wanted to square this, how many terms am I going to have? Let me change to blue. The orange isn't showing up real well. If I were going to do this, how many terms would I have? Is everybody okay? I'm going to have 3. Is it easy to come up with what goes here? What's the first term? 1. Okay. What's the last term going to be? Happy face. And then what's the middle term going to be? Plus 2 square root of happy face, right? Are we okay with that? Does everybody see what happened here? Okay, there you go. I need to make sure. Does this make sense? Okay. See that 2x plus 5? I want you to think of that as your happy face. So if you think of this as your happy face, what goes here? A 1. What goes here? 2x plus 5. Everybody okay with that? What goes here? Two of those, right? See how we have 2 happy faces? Whatever our happy face was, we get 2 of them, right? So if your happy face happens to be 2x plus 5, we're going to get plus 2 square root of 2x plus 5. Now, here's the most important part. Do you see that this problem is the same as this problem? If you can look at this and say, oh, that's just the same thing, except I got a little weird happy face where the happy face is 2x plus 5, then you're where I need you to be. You see those are the same? Perfect. So, what if I give you, let's do the square root of 3x minus 2 minus the square root Has everybody written it down? yuck. Like before, when I would give you things with 2 square roots, one was real simple, wasn't it? Like one was complicated and one was real simple. And so when I give you things with 2 square roots, you go, well, I'll get the complicated one by itself, right? Get the complicated one by itself, get everything else on the other side, square both sides, and I can do all that stuff. What do you do when both are complicated, right? Because these are both look like the same level of difficulty, don't they? Like, what do you do? Well, pick one. Which is the easiest square root to get by itself?
3x minus
This is easy, right? Because what do you do to get it by? What do you do to get this by itself?
10.
Move that over, right? Okay. So let's see. That's going to give me the square root of 3x minus 2 is equal to 1 plus the square root of 2x plus 5. We okay with that? Like we got to get rid. All right. So what do you think we're going to do now?
Square.
Square both sides, right? That's kind of what we've been doing all day, isn't it? Get a square root by itself, then we're going to square both sides. All right. So I square both sides. You know what? I'll do the hard one. When you square this side, you're going to get 3x minus 2. When you square this side, what do you get? 1 plus 2 square root of 2x plus 5, right?
Plus.
Does everybody see where we got this? It's almost like I had a plan, right? All right, now what?
Get the square root by itself.
Get the square root by itself. To get our square root by itself, we got to move all this other junk over. Okay? So to move all this other junk over, well, let's see, if I subtract 2x from both sides, I get an x. Minus 6, I get a minus 8 is equal to we okay with that? Now, all right, now we're going to talk about sort of a judgment call. Could you get the square root by itself at this point? What would I need to do to get the square root by itself? Divide both sides by 2, and you could do that. Here's my issue. If I divide both sides by 2, am I going to get a fraction on this side? And I don't know if you remembered this, but I don't like fractions, right? And so if I can avoid fractions, I want to avoid fractions. So what do? Well, you can still square both sides here. So if I square both sides, what's the left side become? Good. Plus 64. And what does the right-hand side become? Yes. But let's, I mean, I do appreciate you did that in your head. But what I'd like to do is just go and say this is going to be a 4, right? Are we okay? When you square the 2, you get a 4? And so it's going to get a 4, and when we square this, we're going to get a 2x plus 5. Is that? Now, guess what you do? What do you do with this? Set equal to 0 and hope it factors, right? Anytime you see x squared and an x in a number, yeah, you probably want to go through and say that that's x squared minus 16x plus 64 is equal to 8x plus 20. All right? Now, gotta set this equal to 0. Whoops, I need to do something real quick. Okay. So when I set this equal to 0, that's gonna give me x squared, that minus 24x plus 44. Huh. How are you gonna break up 44?
22 and
22 and 2. So x minus 22, x minus 2. So what are my answers? 22 and 2, right? Are we done? Nope. We got to check to see if stuff works, all right? And, you know, that's a little uglier, right? You got to go through. I'm going to pick the, let's see if I do 22, and 6 times 22 is 66 minus 2, 64. This gives me an 8. 44, 49, 7. 8 minus 7 is 1. That works just fine. When I plug in, all right, you've got homework in OneNote. I didn't get quite to the end, so if you have trouble with the stuff with rational exponents, we'll pick up there tomorrow.
Thank you, Mr. Rowan.